Okay, so if you turn to first of all, just a reminder, if you're taking March 14th, you have to actually sign up by February 27th for the SAT. That'll give you May and June as possible retakes. Hopefully, I pray, so I'm just praying you hit it out of the park on that day and you're done. Okay, so we're going to let's, I'm on page 490. I just want to look at the formula page for a second.
If you want to write it down, I guess you can.
Okay, so on 490, we conquered circles last week. And so today, look at this. They're so generous, they give you the area of a rectangle, but they don't give you the um, quadratic formula or circle on a coordinate plane. The area of a triangle, the Pythagorean theorem, and then 30, 60, 90, and 45, 45, 90. So since this is on their formula page, that means you can probably expect it. Then a rectangular solid, a cylinder, a sphere, a cone, and a triangular prism. So those formulas are there for you. So let's go to the first page of the packet. Let's see. Yeah. Okay. So first thing is pretty easy. The angles always add up to 180 in a triangle. So let's go to page 297. This will almost insult your intelligence, and we're going to try number one. So we have a triangle like this. Okay. And so this is 31. Sorry. This is 2B. And we're trying to get A. We know they tell us A is going to be 45. So we add up 45 and 31, and we get 76. Subtract that from 180, 104. So 2B is 104. So dividing by 2, it's A 52. Thank you, College Board. I'm not even going to ask if you understand that because I'm sure you do. So let's try a little bit of a harder one. We're going to go to page 612, number 3. The wrong page here. I think I have the wrong page. 1 second.
Oh, it's gonna be number 2.
Yeah, number 2. Sorry. Okay, in triangle RST, and this is higher difficulty. This is a module 2. So R is 63. which could be S. So we're seeing what S would be. And that's all we've got. So we know 180 minus 63 is going to be 117. And we know that angle S has to be less than 117 because there has to be something left for T, right? So does everybody see that's going to be A? Thank you, College Board, for 10 points. That's good. Okay, we're going to go back to the packet. In the figure above, this is still on page 1. Side DF of triangle DEF is extended to point G. What's the value of X? Well, we know every straight line is 180, so this has to be 100. So we have 130, 180 minus 130, X has to be 50. We're good with that one? Yeah. Okay, now sometimes they embed triangles in a triangle. So if you look at this one, we're going to look at this lower triangle first. So if that's 40 and 120, that's 160. So this little guy has to be 20. Then we can extrapolate out to the bigger triangle. This is 30 plus 70 plus we have a 40. So what would X be? Well, we have 140. We know every triangle is 180. So this would be 40 degrees. And this is sometimes just a refreshing because it's been a while since you've had geometry. Okay, let's look at this number 3. A little trickier. So these arrows are all the same, so that means these are equal angles. So there's a theorem, but you don't have to know it, that the exterior angle of a triangle equals the 2 remote interior angles.
You labeled so they could see,
Yeah.
or just like mark them.
Okay, this angle and this angle has to equal
Why?
y. And so, but let's try picking numbers. Say y is 100. This would be 80. So we can pick numbers in geometry even. So these two guys will be 50. This will be 80. Vertical angles, these will be 50 and 50. So we'll have 200 for these 4 angles. So that means that equals 2y. Does everybody see that one? CLR, Julia, good. I have my smart math princesses with me here tonight. Okay, so let's go on. So the exterior angles of any triangle add up to 360.
And any polygon, right?
Or any polygon, yeah. So let's go on to the next page. So Z is 40. So that means this is 140. Thank you. So we know all the exterior angles, X plus Y plus 140 has to equal 360. We subtract the 140. And so X plus Y has to be 220. So that makes sense? Okay. Okay, here's another one. So we have 125. These are exteriors, so we just take 360 minus 125, and that would give us 235. Pretty easy, right? Okay, now the next one, they love hexagons because this is foreshadowing coming attractions. It has It's made up of 6 equilateral triangles. Do you see that? In a hexagon. So we can just say, okay, it has 6 sides, so 360 divided by 6 of these x's, because it's a regular polygon. So each one would be 60. I could even like look at this like a Ferris wheel and say, okay, that's 360 divided by 6. So this angle has to be 60 and all the other angles have to be 60. So this will be, the bigger angle will be 120. Just a preview of coming attractions. So let's go on to the next page. So they sort of put this back on the test. We hadn't seen it in a while. So in triangle ABD above, ABD is a right triangle. So it says, which of the following is the greatest? Well, the greatest angle has to be opposite the biggest side. So does everybody see AD is going to be our longest side, right? That's pretty common sense. Okay, here's this triangle. Which of the following must be true about P, Q, and R? Well, P is going to be the smallest. Then the next guy up will be R. The next last one up will be Q. So that's A. You're all good with that? Okay. I know we're just warming up here. So which of the following must be true about this triangle? Well, we have 90 and 55. That's 145. So that means this little angle has to be 35. So the smallest side has to be opposite B. So we know AC is going to be less than AB, which is going to be less than our largest angle, the hypotenuse, which is BC. So this has to be this one.
2 only.
Oh, 2. I'm sorry. What was I smoking? I'm sorry, guys. 2 only. It has to be B. So that makes sense? Okay. Okay, and the next page. Oh, we're on the still on this page. Triangle inequality theorem. So one side of a triangle can be equal to or longer than the other 2 sides combined. So, like for example, if I have triangle ABC, it makes sense, doesn't it, that get different color here. That AB has to be shorter than going way up here and way down there. Doesn't that make sense logically? All right, so could I have, I'm trying to find the one that won't work. Could I have a 1, 1, 1 triangle? Sure, because 2 is bigger than 1
Equilateral, right?
equilateral. Yeah. Could I have a 1, 2, 4 triangle? No, because it would crash in on itself. Does that make sense? Because to go all the way up here and all the way down here, that has to be less than 4. So this is our odd man out. That won't work. Make sense? Okay. 2 sides of a triangle each have a length of 6. We're trying to find the third side. Could it be 1? Sure. Could it be 4? Sure. Could it be 7.07? Sure. But could it possibly be 12? No way, right? Because,
Parallel lines.
yeah, to go all the way up here and all the way down here, that has to be bigger than 12 for it to be a triangle. So that one's E. So on the next page, Oh. Triangle ABC has sides that are integers. It means whole numbers. So could I have a 10, 10, because and these ends have to, that means they're equal. Could I have a 10, 10, 20 triangle? No, because to go all the way up here and all the way down there has to be bigger than 20. Okay. Could I have an 11, 10 triangle? No, because these ends have to be equal. It's definitely an isosceles. Could I have,
They can't be 10.5 because it says they're integers.
right, they're integers. Could I have 22 and 20? Could I have a 42 perimeter? Yes, because 11 plus 11 is bigger than 20. Everybody sees that? I know, it's probably been a while since you've had geometry. And the last one, now when they say figure not drawn to scale, that means you can't use your eyes because this is a 2 length and this is a 12 length. Could I have a 6, 2, 12 triangle? No. Could I have a 10, 2 triangle? No. Could I have a 12, 2 triangle? Yes. And why couldn't I have a 14 triangle here? I couldn't because 2 plus 12 is 14. Do you see that? Okay, good. Now there's 3 unique types of triangles on the test: equilateral, isosceles, and right triangles. So moving on. So equilateral, all the angles are 60 and all the sides are the same. Whoops. With an isosceles triangle, the 2 sides are equal and the opposite angles are equal. And they'll often put this one in a circle. So you have to sort of see that, and they won't tell you, but you can see that all the radii in a circle are equal. So if there's any triangle in a circle, it qualifies as isosceles. So right triangle, we just know that a squared plus b squared equals c squared. So let's have you we're just warming up because I know it's been a while since some of you have even had geometry. So what type of triangle would this be? This is going to be equilateral. And all the sides are 6, and this is 60. Pretty easy, right? So far. Okay, this one, this is isosceles because we have 50 and 50. So if this is 4, this opposite side has to be 4. And we know it's not a right triangle because it doesn't have this designation. So it has to be marked like this.
Even though it may look like a right
Right,
triangle, that figure not drawn to scale is important.
right. Okay.
Oh, this one really doesn't look like it's
Yeah.
drawn to scale.
Yeah. So you say, Mrs. Hesser, what were you smoking? That does not look like 105 degrees, right? But I covered my back by saying it's not drawn to scale. You don't have to know this word, but it's called scaling because all the sides are opposite.
Different, right?
Different, yeah. So we have to, so the smallest side will be BD. Wait, I better figure out what B is. So this will be 150. So I have to go to 180. And like I said, we're just warming you up for the difficult problems. So the shortest side, even though it doesn't look like it, is going to be AD. The next side up would be BD. And then the biggest side is obviously going to be opposite that, which will be AB. So we're all good with that? And then they give you this formula on the test. What people usually make a mistake and try to do is you have to multiply it by a half. The area is 1/2 the base times the height. So let's try some. So try the first 3 triangles. Thank you.
Mhm.
Okay. So everybody get the first one was 24. Just want to train you to always remember to multiply by a half. This one would be 20. Sometimes in an obtuse triangle, the altitude will be outside the triangle. Now I'm going to draw this one on another page. So we have here our first segue, and we're going to go through these triangles so you memorize them. So if you have an equilateral triangle, remember on the harder geometry, all you have to do, they don't tell you this, but if I drop an altitude, do you see that's going to create a 30, 60, 90 triangle?
2 of them,
Two
right?
of them, right? Does that make sense? So just drop the altitude and then,
And they give you that formula on the formula page, so you can always
yeah,
look at it when you're taking a test.
but we're going to, yeah, the 30, 60, 90. So opposite the 30 is our x. This 8 is our 2x. So x is 4. But we need the height, which is opposite the 60, which will be 4 square root of 3. So what we're doing, 1/2 times the base, which is 8, times the height, which is 4 square root of 3. So that'll be 16 square root of 3. Thank you, College Board, for 10 points. So is everybody good with that? Sailor, are you good? Julie's good. Gabby, you good? Okay. So let's try a book one. Oh, I'm already in this. Okay, we need to go to 841, number 19. See what awaits us there. Okay, so we're in the hard zone. We're in a module 2, deep in a module 2. Okay, so no, it's module 2, lower difficulty. So we have an equilateral triangle. If you had your scratch paper, I'd probably draw it. Okay, the perimeter of an equilateral triangle is 64, 641, right?
No, 624.
Okay, sorry. That makes sense. So we're going to divide that by 3. So each of these sides is 208. Does that make sense so far? The height of the triangle, and you almost have to draw this, is going to be k square root of 3. So I know I have a 30, 60, 90 right triangle here because we've sort of trained ourselves to see that. So 208 is my 2x, right? So x opposite the 30, I divide these both by 2, and x would be 104. And then opposite the 60 would be x square root of 3. And so x has to be 104. Now, I don't know if I went, and those are harder because you don't have a number to base it on, you know? So if you'd like to see it again, just raise your hand. I'll go through it slowly. We're okay, Sailor? Julia, you're good? Abby, you're good? Oh, you really are math princesses. Okay, that's awesome. Okay, on the next page in the packet, so you can figure out the total number of degrees in the interior angles of most polygons by dividing the polygon into triangles. So like this is a formula, but you don't really have to know it. There's 6 sides to the hexagon. 4 times 180 is 720. We mentioned this earlier. So each of these interior angles has to be 120. So this x bisects it, so x has to be 60. Oh, I can't write very well on this class. Thank you. So I could also make this like a Ferris wheel. There's lots of different ways to do it. This would be 360. So each of, and we mentioned this before, that each angle in a equilateral triangle is 60. So do all three of you see that 60? Oh, good. And like I said, we're sort of getting you back equated with geometry. So here, now you'll definitely have a similar triangle question. And they have the same shape. So in other words, angle B will equal angle E, but the sides are in a ratio. So we'll have 3 is to 9, as 5 is to 15, because we're multiplying by 3, and as 6 is to 18. So then the perimeter of the triangle will be 24 plus 18, which on this planet is 42. Okay, so let's try some book ones with similar triangles, because you'll definitely encounter one. So we're first going to go to page 962, number 2. This will probably be easy. But this is higher difficulty already, hard to believe. I would take the time to draw it on your scratch paper just to keep everything. If you keep everything organized, you won't miss this question.
So M and Q are not right angles for this.
Oh, that's right. I keep
I
forgetting.
mean, they are right triangles though,
Yeah,
but it's just not M or Q. They
yeah,
can't be the right angle because they give us the angle.
yeah. So we have LMN, and that's similar to PQR.
Okay, but Q and M aren't the right angles.
I
I was
know,
trying to say that.
I know.
Okay. They can be any of the other
Anything.
ones.
They can be anything. Yeah. So anyway, angle M has a measure of 53 degrees. What is the measure of angle Q? It's just going to be B 53 degrees. Do you see how easy that is? As long as you just draw it and keep yourself honest with what's similar to what. And that was a higher difficulty module to a question, admittedly, in the beginning. Okay, so let's go to 1065. So we're looking at number 9. So triangle ABC is similar to triangle XYZ, where A, B, and C correspond to XYZ respectively. In triangle ABC, the length of AB is 170 and the length of BC is 850. We also know that YZ is going to be 60. So we know the ratio is the same. So we can say basically 170 over 85,
Over 850, right?
850, sorry, equals this will be X over 60. And we can just cross multiply that. And so you should get 12. A little different turn on that one, but does everybody see it? Oh, good. Debbie, you're good with that one? Okay. Awesome job. Then let's go to 1070, I guess on that same test. And we're going to look at number 7. I'll write this up for you. Sorry. Okay. Triangles ABC. Again, I think it pays to just write these off or draw it on your scratch paper. Because if you try to keep it in your head, there's too much chance for an error. And the problem just pretty much falls into place. A corresponds to D, B and E are right angles. The measure of A is 18 degrees. What is the measure of angle F? Well, angle F is going to equal angle C. So if we have 90 plus 18, that's going to be 108. And we're going to subtract that from 180. And so the angle F, this has to be 72. And so F has to be 72, which would be B. Thank you, College Board, for 10 points. We're all good? Thank you. I mean, like I said, these problems are pretty simple. Let's try a hard one. Let's go to 494, number 8.
Might be 18.
Oh, sorry. Thanks, Jim. Okay, this is in a module 2, so this is higher up. So we have a triangle. And we know these triangles are similar because of angle, 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 right? 90, 90, these are both equal. And so these apex angles have to be equal. So we have similar triangles, and AC is 3. I think it pays to draw the triangle on the test. B is the square root of 34. And our job is to get the area of the whole big triangle. So to get the whole triangle, and we're higher in a module 2 now. So we have to get 1/2 the base times the height. Okay, so we have to find this height. So right now we can use the Pythagorean theorem, which is a squared. We're going to hit it in a second. So that's going to be 9 plus what we don't have, b squared, is the square root of 34 squared. So then the radical cancels the exponent. We'll have 9 plus b squared is 34. Subtract the 9. B squared is 25. So b has to be 5. So this height has to be 5 just by using the Pythagorean theorem, which you all know. Now we know this little guy is similar to the big triangle. So we have to try to find what we have to do now is find out.
Oh, they also tell you CE is 21.
Oh, okay, that's the missing piece.
Right.
So this is 21. So this whole base is 24, right? So the little triangle is, you see, 24 is 8 times, or I could just do 3 is to 24 as 5 is to DE, because we need to get that big. And then I can just cross multiply. So DE is 40, which makes sense because we're doing 5 times 8 is 40, 3 times 8 is 24. Now all I have to do is go back to the 1/2 BH, 1/2 times 24. And these are the hard ones because you don't have any number there to rest yours.
You have a number?
Yeah. And so that'll be 12 times 40, which is what, 540?
480.
480. Yeah. Now take a minute and digest that one because that was a little harder. So we're just trying to get you really familiar with all these questions. Julia, you good? Sailor, good so far in that one? And Gabby, awesome job. Okay. So now, okay, so we conquered that page pretty much. Did a couple easy and a couple hard ones. Now our Pythagorean theorem page. And since they put this on the test, you know you're going to see it. And c squared is always the hypotenuse. I'm just reviewing because it's been a while since you've had geometry. So for this one, if I have to find x, I can draw that line, right? And that means that 6 squared plus 8 squared is c squared. 36 plus 64. So 100 is c squared, so c is going to be 10.
And they like those 6, 8, 10, 3, 4,
Yeah,
5.
we're gonna go into that. Yeah, 3, 4, 5. So now we hit it this way. Now we can hit it this way. So 9 squared plus x squared is 10 squared. 81 plus x squared is 100. Subtract the 81, and so x squared would be 19. So x will be the square root of 19. Okay, good sailor, Julia, and Gabby. Good. Okay, here's our, if you can do this one, you can do sort of any kind of triangle problem with the Pythagorean theorem. So we have a ladder. It's placed against a vertical wall. That means this is 90 degrees. And the bottom of the ladder is 14 feet from the base. So the ladder's 50 feet. And we have a painter going up here with his can of paint. Okay, but then not a big catastrophe, no need for an ambulance. But the ladder's gonna, so we know we have to get, eventually we're gonna have to get this height. So the ladder's gonna slip down 8 feet. So this will be h minus 8. Notice the ladder's going to stay the same, and we'll just have the guy fall a little bit and lose all his paint. You can't make math fun, but okay. So now our mission is to find this one. But we know, so take the time to put this one in the Pythagorean theorem, find the height, then have the height go down 8. And so find x and see how much you had to jump out. And I'll just do it here too. So then at the height, it's going down 8 feet, so this will become 40. So did everybody get the first height was 48? Good. I get, oh, this is just familiarizing you. So now it's going to go down 8 feet, so it's 40. So we will have a 30, 40, 50 triangle because it's 3, 4, 5, which we're going to see on the next page. So to go to 14 to 30, it had to go out 16 feet. So you're all bright math princesses. So it works? Yes. Okay, good. So we want to try a couple of these Pythagorean theorem ones. So first one is pretty simple. 492, number 1. We'll just do a couple of these. Higher difficulty, but it's a number 1. So we have a right triangle, legs of 11 and 9. So all we have to do is go into the Pythagorean theorem. So everybody sees it's B? Not so bad. Okay, let's jump up to another one. Let's go to 1072, number 11. And all of this is so on test day, you're not like, oh, I had geometry 2 years ago. How can they expect me to know this? There's no proof, so there's only one trig identity, and we're going to go over that tonight. So 1072, number 11.
I think it's number 14.
Oh, 14, sorry. Yeah. So we know A is 4, B is 5, and so we're just going to do 4 squared plus 5 squared, c squared, 16 and 25. And that's the square root of answer choice D. Actually, they left it up here. So are we good with that? Pretty manageable one. Okay, so let's now go to 963, number 11. So hopefully this is dusting off the cobwebs from your geometry days. Okay, that isn't too bad.
You're doing number 9
Oh, I'm
first.
first.
You
Yeah.
can.
Yeah, let's do number 9 first, guys. Sorry. A circle has a center O and points B and S line on this.
R and S.
Oh, sorry. R and S, and they form a triangle. Oh, that looks so pathetic, the wiggly lines, but the measure of ROS is 90 degrees.
It's 88.
Oh, sorry, it's 88. Okay. And we have to find RSO. So we're trying to find this angle. So this is what I was talking about earlier. So you have to know that, the triangle embedded in the circle is isosceles. So if we take 180 minus 88, we get 92. And we're going to divide that into 2. So each one, so RSO would be 46. And that's a higher difficulty one. So you just have to recognize, just getting you acquainted with the radii are equal. Gabby, you're good. I know all my princesses are good tonight. So let's try 11, because it's a little wickeder. Is that a word? More wicked. Sorry. So this test had 2 right in a row. A right triangle,
The legs are 24 and 21.
24 and 21,
And the hypotenuse is 3 square roots of D.
3 square roots of D.
So Pythagorean theorem, right?
So we're going to be using the Pythagorean theorem. So that'll be 24 squared plus 21 squared is 3 square roots of D squared. But do I have to square the 3? Yes, because it's in the parentheses. So 9D will equal, and when these two add
It's
up,
576 and 441. And together that'll be 1017.
then all I have to do is
Why are you dividing it by 1017? That doesn't.
no, I'm
You're
saying,
dividing it by 9, right?
yeah, I know. I was just saying, it was a bracket that equals that. Sorry. So 576 and 441 is 1017.
I'm going to give you more space because I think that's the problem here.
Yeah, so I divide 9 into 1017, and I get 113. Thank you, College Board, for 10 points. Does that make sense? And those were 2 on a higher difficulty test. And actually, there was number 2 was also on that test.
Oh,
So
right.
that's 3 of them. Okay. And one more, 84. Did we do 841, number 22? We probably did. Let me just check.
You did not.
Okay, now we're going to do 841, number 22.
They would expect you to use a calculator for this one too.
Did I say number 22?
Yeah, 841, number 22.
Oh,
It's not hard. It's just you knew you would need a calculator. It's a lot of decimals.
oh, okay, yeah,
But I'll read it to you if you just draw the triangle.
yeah, okay.
Okay, so it's a right triangle. One leg is 43.2.
Uh-huh.
The hypotenuse is 196.8. And they want the other leg.
So they want,
Call it X or call it whatever.
okay, yeah. Okay, so we just have to crunch numbers, so
Yeah, so you have 43.2 squared.
that's what, 18?
I'll read just write it out first and then
Yeah.
I'll read it all out because you would need a calculator.
Yeah, you have to use a calculator. I think these girls are already at it.
Yeah, they'll beat us probably. So that's squared plus x squared equals 196.8 squared.
Okay,
Okay, and then get you some more room.
yeah,
Okay, so it's going to be 1866.24 plus x squared equals 38730.24.
38730.24.
Yeah, 0.24.
So we just subtract this.
Yeah. And then x squared should be 36864. Square root of that, drum roll, answer choice C, 192. Did they get that same answer?
Did you get that same answer, Sailor? They beat me at it.
The hardest part about that one is just all the decimal points.
Yeah, just number crunching. Okay, that was enough Pythagorean theorem for a lifetime. So, but you can see they pepper the whole test with this stuff. So let's go back to the packet. Okay. So these are the special triangles that are all over the test. These first two, they don't give you. But because the numbers work out so pretty, you guys probably remember 3, 4, 5 triangles, right? A little bit. And then also 5, 12, 13, because the numbers work out so well. So these are the ones that they're on the formula page, but if you sort of commit it to memory, then you're going to know.
So these are often in squares.
Yeah, we spelled diagonal wrong. What the heck?
Oops.
So if this is 45, this will be 45. And this will be x squared root of 2 because that's a little bit longer. Okay, and so then the next one, we sort of already had a little bit of acquaintance with it. So opposite the 30 is x, opposite the 90 is our big 2x, and opposite 60 is x squared root of 3. So they'll give you those on the formula page, but we just want you very acquainted with it. Okay, so can you put, maybe with or without the formula page, can you put these expressions where they belong on that triangle? We're just trying to sort of embed it in your brain. So opposite the 90 would be our 2x. Opposite the 30 is our x. So your triangle should look sort of like this, right? Okay. And then if you know one side of a 30, 60, 90 triangle, you can determine all the others. So if the short leg is 2, thank you.
Sorry, just trying to get it all on.
Yeah.
Yeah.
This will be 2 square roots of 3, and the big hypotenuse would be 4. The big hypotenuse is 6, that's our 2x. The little leg would be 3, and this would be 3 square, that's 3, sorry. Oh, this glass. So if this is 4 square roots of 3, this will be 4, and this would be 8. And if this is 3, we're going backwards. So this would be the square root of 3, and this would be 2 square roots of 3. So that's our 30, 60, 90. See, they can't put a whole bunch of crazy stuff on the test. So can you put these terms on this triangle, just following along so that you can sort of get the, so these will each be x, and this larger angle will be x squared 2. So that's good. So we're going to try a couple book ones. The first one we'll go to is 614, number 17.
Oh, we picked a pretty tricky one.
Uh-oh.
It's good. It's a good one, but definitely a hard one.
Oh,
You're in the
no.
higher difficulty module, end of the test.
Oh, we're at the end of the test, guys. Yikes.
Watch it. Your next example is going to be really easy, I bet.
Probably. No, we're
Just go for it. Why not?
all right. We'll do this hard one.
So a rectangle is inscribed in a circle.
Remember, we did one like this last week. This is in the hard zone.
Okay. The diagonal of the rectangle is twice the length of the shortest side of the rectangle.
So the diagonal, which is the diameter of the circle, even though my circle looks like a flattened pumpkin or something, this is x, and that's 2x.
Yeah.
What's our job?
Okay, then they say the area of the rectangle is 1089 square roots of 3. Okay, and now they want the length of the diameter of the circle. They want the 2x.
So they're looking for
2x.
2x. I can't. Okay.
Oh, yeah. So
So we know the length.
what we need is the height of that rectangle.
Yeah,
Because we have the
we
width.
need an x. So there's only
Well,
one.
we have an x. We need the height.
Yeah.
So we know it's a special
Yeah.
right triangle, right?
There's only one triangle in the universe. So this little angle has to be 30. The 2x has to be opposite our 90. So this height has to be x squared root of 3, right?
Right.
So now we know the width is x, the length is x squared root of 3, and that equals 1089 square root of 3.
Divide everything by square root of 3.
Divide by everything by the square root of 3. This is a hard one. I didn't mean it.
Yeah, you must be.
Yeah.
So
So
x squared.
x squared is 1089.
Yeah. So
So
x is 33,
x
but
is
we didn't want
33.
x.
We want the whole big, remember we need the
We need the
diameter.
2x.
We need the 2x, so that would be 66.
Right.
And that's hard because you're out on your own. So should I go over that one again? Let you digest it. You got it, Sailor?
That's
Julia?
It's a very nice picture.
It's horrible.
It's so hard to write on the screen. You gotta give us a little slack.
Yeah, so we just conquered a very hard one. So let's go on to the next page.
So there's only one right triangle where the one side is double the length of another.
Right. And that's a 30, 60, 90. So we're just going over the geometry. You spent a whole year on geometry, but we're just going over. So we're back in the packet. We conquered that. So we're doing exercises on the next page. So here, in the figure above, what is the area of square ABDE? So I have to get us the side of the square. So instead of, they made it sort of the roof of a house, but I still can think of it as 7, 7. This will be 7 square roots of 2 for the hypotenuse. So each side of the square is 7 square roots of 2. And so I multiply that times each other. and I'll get 49 times 2. So that one is 98, not too bad. Does that make sense, Gabby? Julia's good. Sailor, you're good. See, and you didn't like geometry, and now it's fun because there's algebra. I just want you to get as many of those 100 points as you can on the test. Okay, so we need to get all the way over here to BC. So we can do the Pythagorean
We can
theorem.
look for those special triangles, right?
Yeah. So this is a 3 times 3. This is a 3 times 5. So the height will be 3 times 4 or 12. And then
They love 3, 4, 5 triangles.
Yeah.
They're all over the
But
test.
you could always punt and use the Pythagorean theorem. So then this will be 4 times 3. This will be 4 times 4. Our missing one will be 4 times 5, which is 20.
So they
Okay.
were both 3, 4, 5 triangles.
Yeah, they were both 3, 4, 5 triangles.
They love them.
So everybody good with that one? Now this one, honestly, we put this in the packet and then it was on test. So they don't have that many tricks up their sleeve. So do you see if I draw the perpendicular bisector here, I will have a 30, 60, 90 triangle. And 105 minus 60 is 45. So this will be 45. This will be 45.
So those are both of our special triangles, right in
Side
one.
by side.
Yeah,
Yeah.
but you have to draw that line.
So 8 is going to be our 2x. So x is going to be 4. So this will be 4. This,
That's 4 squared is 3.
I'm sorry. This will be 4, opposite the 30. So if that's 4 and that's 4, so now we have on the right, we have a 4, 4, 4 square roots of 2. And so that'll be answer choice B. Now, that's a hard one. Does that make sense to anybody? Sailor's okay, Julia's nodding. Gabby, you good? Okay. All right. Okay, let's go on to the next page. So we just wanted to expose you to as much triangle as you can. So like last week, just try 5. And then we're going to go over them all. And don't do number 10 because it's too difficult. Number 10, no 10. But just try any 5 problems. We'll give you some time to do that. You are worker bees. So let's start at number one and we'll go through them. I just wanted you to, if the ones you did, to see if you got right, but you're my math princesses for sure. So in the triangles above, what's the average of A, B, C, D, and E? Well, A and B add up to 90, C, D, and E add up to 180. So that's going to be 270 divided by 5. And the answer for that will be 54. Thank you, College Board, for 10 points. Okay? Now the next one, to get the area of the square, well, we need the sides. So we know it's a square, so we know it's 90 degrees. So we can do x squared plus x squared is c squared. And so that would be 2x squared equals 36 divided by 2. And x squared, we have it, it's 18. We don't even have to go back to the side. We could just say that'll be 18. Does that make sense? Okay. Now, sometimes they put steps on the problem, on the test. So do you see if this is 8, this has to be 5 plus this has to be 3, right? It's a 90-degree angle. And if it's 9 all the way across here, and this is 5, this little segment has to be 4. So we know from earlier, we have a 3, 4, 5 triangle. The hypotenuse has to be 5. We add up all the distance around, which will be 15 3/5 plus 17. And that'll give us 32, which is answer choice D. Everybody okay with that one so far? Now we're moving into a harder zone. So this one is very tricky. So we don't shy away from the hard problems. So this is just sort of a ruse. They want you to try all this, but we're just going to focus. This is 30. This is 60. And we have a 30, 60, 90 triangle. DE is 8 square roots of 3, which is our 2x. We have to try to find FE, which is the side opposite the 60. So if this is 2x, opposite the 30 has to be our x, which is 4 square roots of 3. And so this is opposite the 60, which is, I didn't mean to draw that, but anyway, it's going to be 4 square roots of 3 times the square root of 3. That's what usually you think the answer opposite the 60. So the square root of 9 is 3. So 4 times 3 on this planet is 12. So I'm going to stop there because that was a hard one. You see it, Sailor? Sort of. Gabby, you're good. And Julia. Oh, the gene pool is good on this class. Okay, let's go on to this one. They love these kind too. So we have to get the shaded region, and we did one like that. So you see, we need the triangle, the area of the triangle, minus the sector of the circle. So this is 60. This is going to be 6 square root of 3. And that's why I wanted you sort of familiar with this. This would definitely be in a harder section. So the area of the triangle is just going to be 1/2 times 6 square root of 3. That'll be 18 square root of 3 for the triangle.
So already it's C or D, right?
Yeah. So we know it's not 9 square root of 3. I don't know what they did there. But anyway, now we need, remember, to get the area of the pizza slice, 60 is what fraction of 360? It's 1/6 pi times 6 squared. And so that'll be 6 pi. And so my answer is going to be C. Now, this is a hard one again. So I'm going to take a minute and let you digest it. So are you good with that hard one, Julia? Wow, Gabriella. Good? Okay, next page. We're in the home stretch and break is coming. We just have to cover trig and okay, so let's look at this trapezoid. The perimeter of the trapezoid is 38. So if this is 10 going across, this has to be 10 going across. So we know we have the whole trapezoid is 38, which equals 10 plus 18.
28, right? Because or sorry, you
Yeah,
have,
10 plus 18, sorry.
yeah, you have 28 of it already.
Yeah, plus 2x, because we don't know what these guys are. But 38 equals 28 plus 2x. Subtract the 28, 10 is 2x, so x is 5. But look, we have our good old 3, 4, 5 triangle again. So now we want the perimeter of the rectangle inside here, which will be 20 plus 6, or 26. Does that make sense, Gabby? And Julia, Sailor, you got it? Now this one is harder because it requires you to draw a line. So if I draw this line, remember I said I could have an embedded triangle in a triangle. So let's label what we know. So what we know here is y is 20. Each x is 30. So if I'm just focusing on this big triangle here, I have 80 degrees, so I have 100 left over. So basically, these two will be 50. Oh, I can't write. This,
You just draw you trying.
okay, so I'm trying to draw this little triangle in here. Oh, dear God. All right, so this is what I'm saying is this has to be 50 up here and 50 down here. So the triangle has to add up to 180, so Z has to be 80 degrees. Despite my awful pictures, does that make sense? Okay, good. This glass is just, it's not my dexterity, really. Sorry. Okay, now this one is hard. So we don't shy away from these, so let's try number 8. A, B, C, D, E, F is a regular hexagon. I told you they love hexagons. So we know if we drop an altitude here, because this will be 120. So this will be 60. That'll be 30. That'll be 60. And this will be 30.
Maybe you want to draw the triangle like outside of it somewhere. Maybe down here.
I'm not very good at drawing these triangles. So we know all the sides are 2, but we have to get this altitude or the length of the triangle. So if AB is 2, so we're going to draw this perpendicular bisector. 60, 60, 30, 30.
And 2 is your 2x, right?
Yeah, so my 2x is 2. So x will just be 1, opposite the 30.
So what's the height of one of those triangles?
So one of these triangles will be the square root of 3.
And the other triangle is?
The square root of 3.
So now she has the height of the whole square that she was trying to get. Maybe just label
Yeah.
That's 2 square roots of 3.
So this whole long thing is 2 square roots of 3. This would be at the very end of the test, obviously. And I'm
So
just,
now we can find the area.
so the area would be length times width. Well, the width was easy. It was 2. And our length is 2 square roots of 3. So that would equal 4 square roots of 3, which is answer choice A. Okay, we'll take a minute to digest that. Everything good with that? And there's going to be a break coming. I promise. Okay, one last problem because we're not going to do number 10. We haven't seen anything. So let's try 9. We want to give you just enough that you feel like you're equipped. So here, the whole AC is 10. And they tell us that ABE, the height of this thing, is 12. And then we have to chunk this all down. So
AD is 2, which
AD,
means FC is 2.
so FC is 2.
And then the whole length at the bottom is 10.
Right.
So if you take out the 4, we know what DE and EF
They
are.
have to be 3.
Right.
Okay, so we can do the big triangle, which is 1/2 times the base, which was 10, times the height, which was 12, which is 60. Then we can get
Like
the
the white triangle.
white triangle. Yeah, that's what I wanted to say. 1/2 times 6 times 12, which is 36. And so the 2 shaded would have to be 24. And I could even see if I get one of these, because remember the altitude goes outside of the triangle on a obtuse triangle. So this would be 1/2 times the base, which is 5.
2.
Oh, I'm sorry, the base is 2, yeah. And the height is 12. So one shaded triangle would be 12, the other would be 12. So either way you do it, it's 24. So that makes sense? Okay, I'm glad I have committed princesses. Okay, so now we're not going to do this one. We're going to go right to trig. Okay, so,
I'm just gonna like zoom it out a little bit.
okay.
They've had this before, SOHCAHTOA.
Yeah, so I'm sure all of you have had SOHCAHTOA. Just nod your head if you've had it. Yeah, good. Okay, so the good news is you don't have to know these. You just have to know sine, cosine, and the tangent.
So that's not on the SAT anymore.
No, this is off.
You'll need it for your regular math classes, but not for the SAT.
Right,
And no cotangent either for the SAT.
right. Tangent is just,
Those could be on the ACT,
yeah.
but not on the SAT anymore.
So let's look.
Used to be on
Oh, we spelled values wrong on this. I'm catching all kinds of spoilers.
it. Oops.
Sorry. All right, can you just do these 3? Okay. Find the sine, the cosine, and the tangent. We know how to spell values some. Okay, so the sine should be opposite over the hypotenuse. You should have gotten 5/13. The cosine is the adjacent neighbor over the hypotenuse, which is 12/13, and the tangent is going to be opposite over adjacent, which is 5/12. So that's all good? Okay. Now, there's only one trig identity that I want. Well, let's first try one in the book. Sorry, I didn't register.
What are you doing?
Trying to get a new document.
I think you're hitting the Zoom stuff.
Okay,
Yeah, don't mess with the meeting because we need the meeting.
I know.
Okay, well, I don't know what you did. What does that say?
Okay.
Chat. Oh, is that the chat? What does this say? What does that say? I can't read it.
It says meeting chat. I just want to hit new document up here. I just want a new page.
Okay, well, you were hitting
I'm sorry.
the Zoom stuff.
Okay. So I want to try 299 number 8. There's only, if you've had higher math, you'll know that there's a lot of trig identities that you can memorize if you need to. So 299 number 8.
So you would always draw the triangles on your scratch paper,
Yeah.
I'd imagine. 'Cause if you try to do it in your head, you might make a mistake.
No, I'm not doing number 8. I'm doing number,
You're not doing number eight? Number eight is similar to
yeah.
triangles. SOHCAHTOA. I think
Okay.
you are doing number eight.
Well, let's try number 5 on 298. I just saw another one. So 298, number 5. I'm sorry. So in a right triangle, the tangent of one of the acute angles is the square root of 3 over 3. What is the tangent of the other acute angle? So if this is one acute angle and the tangent is opposite square root of 3 over 3, the tangent of the other angle would have to be 3 over the square root of 3, which have to be d. Does that make sense?
Hey, Mrs. Hessler,
What?
if you were putting together your fancy College Board textbook, would you make the answer choice an unrationalized denominator?
I don't
Look at
know.
that. Look how
Okay.
lazy they were.
Okay.
That's 3 squares of 3 over 3.
Yeah.
Please, rationalize your fractions.
Okay, let's go to the next page and we're going to do number 8. So triangle KLM is similar to triangle QRS. And again, we take the time just to draw these because people get intimidated by this, but it's very easy when you keep your everything straight. Angles L and R are right angles. Okay. If the sine of K, so the sine of K is going to be 105 over 233. And the sine of M is going to be 208 over 233. What is the value of the tan of S? Well, the tan of S is going to be the same as the tan of M, right? Which is opposite over adjacent. So we're going to do opposite 208 over adjacent 105. And
Oh, here's the other interesting thing. How many characters can you put in for a positive answer?
5.
5. So
So
you can't actually enter the right answer as a fraction.
you'd have to move it,
I'll,
put it,
I'll, I'll tell you the acceptable answers.
okay.
So you can write them down. 1.981 or 1.980.
Okay. So that's,
It doesn't even fit in. You would try
yeah,
to type it in and you'd realize you don't have enough room for it.
yeah. So you have to change it to a decimal.
Right.
We're trying to,
But that can happen sometimes.
okay, now there's one, back to the packet. There's only one trig identity you have to know. And we had trouble on Sunday with a princess who didn't quite get this. So I'm going to write it out right here as best as I can on this glass. So
So sine of theta.
the sine,
Or just write it out in algebra.
okay, I'll just
Just
do
give
the
me
algebra.
algebra. Yeah. So
Okay.
sine of theta,
So the sine of an angle
call it theta,
equals the
equals
cosine
cosine of 90 minus theta.
of the complement.
You're not enough room. Yeah, 90 minus theta.
And also the cosine of theta would equal the sine of 90 minus theta.
So that's the only other
The only
identity you need
identity,
to
the
know.
only one.
So if you know SOHCAHTOA in this fact,
You're
you're good for the SAT. That's all you need.
right.
You don't need any of those sine squared, any of those other crazy ones.
So this sort of proves it. So the cosine of 23. So you see the cosine would be the adjacent over the hypotenuse, right? So the cosine of 23 would be AB over the hypotenuse AC. And so do you see that would be the sine of 67? Does that make sense? Because it would be AB over AC. Does that make sense to everybody? Oh, thank goodness. So it would be the sine of 67. So we'll try a couple book ones. What was that one? Was it
I
834?
can find, well, look.
That one.
You want that one first, or you want to build up to that?
Okay, let's try 834. Then all we have to do after this is solve geometry. 834,
Number 16.
number 16.
I'll find that one for you whenever you need it. But let's do that one last for
I
the,
think it's 721.
oh, it is. Yeah, it is.
So 834. Okay, we're doing number 16. In triangle RST, the sum of the measures angle R and S is 90. So that means T has to be 90. So we have a right triangle. The value of the, what's it say, sine of R, the sine of R equals square root of 15 over 4. And they're asking us for the cosine of S. So you'd see it would be the sine of R would equal the cosine of S. Everybody see that? The sine of R is going to equal the cosine of S. So we could just say square root of 15 over 4. You guys all got it? Yay. Okay, the harder one was what? 720.
721, I think.
Okay, we'll go to a harder one, and then we just have to do solid geometry. And you have
It's
a
number
break.
22.
This is a hard one because it's the end of a section. Okay, 721, number 22.
Yeah.
It says, which of the following is equal to? So we have the sine of 24 times, what does it say, cosine?
Cosine of 66
66
plus the cosine of 24 times the sine of 66.
Thank you.
Oh,
Yeah. I just wrote the problem out here. Okay, so we already know that the sine of 24 equals the cosine of 66, right? Because they're complementary. So the cosine of 66, and this is like the hardest one, equals the,
so it's the cosine of 24 times the sine of 66.
okay, so that's going to equal the cosine of 24
Yeah.
times the cosine of 66.
No, the cosine
Cosine
of 24.
again.
Yeah.
Sorry.
There you go.
So it'll be answer choice C. The cosine, this is a hard one, but if you know that one little identity, people think trig and they think, oh, this is going to be so hard. But it's really not. Plus the cosine 24. So, Sailor, you got it? Julia, yes or no? Not really. She got it. Gabby, we had a princess on Sunday that just didn't get this. Okay, so back to our packet, and you'll be happy about the next step here. So back to the packet. So here, pretty easy. We have a right triangle. So we know 12 and 35 have to be the legs. 37 has to be the big hypotenuse. What's the cosine of the angle opposite the 35? So we need the cosine of this angle. We'll call it A. So the cosine of A equals adjacent 12 over the hypotenuse, which is 37. So that'll be answer choice D. And we're done with trig. So there's the mystery of all those other crazy things you need to know, you don't need to know in the test. Okay, so now we can skip through these next pages because there's no inverse trig. So no lighthouse.
My lighthouse.
It's gone.
You know how long it took to draw that?
I don't know. Oh,
The
well,
waves. I drew the waves.
you drew the waves. Let me see. Oh, you drew the waves. Okay.
Oh, killing
Okay.
me.
And inverse trig functions are not on the test. So we don't need to know any of this.
Well, you should know this, but for your regular math classes,
Yeah.
not for the SAT.
We don't have to know the
It
kite.
used to be on the SAT.
Yeah, the sol's off.
My kite.
Now we're on solid geometry. Our last thing. Hallelujah. Okay, you ready? So hang on, just a little more of the breaks coming. So these are the figures they give you. So notice they give you the volumes. They don't give you the surface area
On the formula page.
on the formula page. The surface area is just the two-dimensional, like how you would wrap a present, right? Does that make sense? So the surface area is just like you would wrap a present. So here, so we have a surface area of a cube. So how many sides does a cube have? A cube has 6 sides. So that'll be 6s squared is 54. Dividing by 6, s squared is 9. So the volume of the cube, the side will be 3. So we just need 3 times 3 times 3, which is 27. Okay, we're going to try a couple book ones here. Let's go to, well, let's finish these and then we'll go to the book. So number 2, we have a square label like a soup label. And it's length 8, it's a square. Mine doesn't look exactly like a square. Wrapped around a right cylindrical can with no overlap. What's the area of the base of the can? So do you see the bottom of the soup label will be the circumference of the can? Does that make sense? Good. So now we know we have to get the radius, remember, with all these circle problems. So 8 equals 2 pi r. So we're going to divide by, we want to get the radius. So 8 over 2 pi. So the radius is 4 over pi. And so the area will be pi r squared, pi, 4 over pi times 4 over pi. So it'll be 16 over pi. So that makes sense, sort of. Okay, this is sort of easy. If you have a freezer that's 8 by 4 by 6, and we're putting little cubes in, we want to know, so the big volume is 8 times 4 times 6 divided by the little volume, which will be 2 times 2 times 2. So we'll take the big volume divided by the little one. And so we could fit in 24 ice cubes. That's not too bad, right? Okay, a couple book problems and we'll be done. So let's try, hang with me just a little bit. The break is coming. 8:45. I know this is it's all going to be worth it because when you see this on the test, it'll be, oh, I've seen that before. Let's try 8:45, number 10. See what's there.
And you can use the formula page if you need it, because you can look at that at 80 times. The
Right.
formula page for this test is on 842.
It doesn't, yeah.
Yeah.
So let's look at number 10. We're in the higher difficulty mode. So this time we have a cube that has a side of 68. And then we have a sphere inside it. So all we have to do, just like with the other, we had a two-dimensional, we just have to take the volume of the cube minus the volume of the sphere. Does that make sense? Okay, so the cube, we'll just tell you.
It's 83 cubed.
So what is the size?
Or sorry, 68 cubed.
Yeah, we know
68 cubed minus
the sphere.
4/3 pi times 34 cubed.
Is it cubed or squared?
It's cubed.
Okay.
So if you put that into your calculator, you should get a 149,796 or something close to that. 149,796.
But I don't care so much about the number crunching. Just so you understand the concept, you're going to take the cube minus the sphere. I know you girls can see that. Okay, let's try 733, number 19. So these are just sort of sprinkled in there.
Oh, this one, the cone thing.
No,
You want to save that for later?
no, we'll dive in. This is a hard one. So I'm telling you, you can have a great life and not solve this, but 732. I just have a feeling that you're going to get one of these. I'm serious because they love these. So let's first try to get the whole thing. So we have a right circular cone.
Can you write out the formula for the cone just so we have it on the page?
Yeah, so
It's volume equals 1/3 pi r squared h.
So I just have a feeling you're going to get one of these. Teacher intuition. And we're trying to get the slant height of the cone. Do you see that all that is going to be?
It's a right triangle.
It's a right triangle. And we just have to get the height. So we just have to use the formula, a squared plus.
Well, you're gonna have to get the hypotenuse, right?
Yeah.
Not the height, or not the.
Yeah, we're trying to get the hypotenuse,
right.
the C. Okay, so let's go on. So the volume of the cone is what is it, 71? Can you just read
Yeah, 71148 pi.
pi? And that equals 1/3 pi r squared h.
Correct.
And then the other thing we know is that 5929.
Oh, we know the area of the base of the cone.
So the base of the cone is going to be
So that's pi r squared, right?
pi r squared
Equals 5929 pi.
So do you see what I need to do here? I need to get the
Divide
radius.
both sides by
I
pi.
can divide by pi, and the square root of 529 is,
5929.
yeah, 5929 is
77.
77.
So let's start drawing our triangle out here, maybe.
So if we draw the triangle out
So the
here,
base will be 77.
so the radius,
So
that's
we got the radius.
we got the, and that becomes the base of the triangle.
Right.
Now, here's the tricky part. You see 7929, if we subtract that, we take out the pi r squared here, and we subtract 71,000, we are going to get,
Oh no, you're not going to subtract. You're going
yeah.
to subtract a two-dimensional
Okay, so
area from a three-dimensional volume.
no,
I don't think
I'm
so.
just dividing this by this. So I'm dividing
Oh, okay. That's what you're
7148
saying.
by 5929. That way I'll get 1/3 h. Hang with me, girls, is,
Okay, so if you divide 71,148 by 5929, you
yeah,
get 12.
12. So then that's pretty easy. The height is 36. And so then I can go on my merry way and get to C. Is there a number? There's a number for this one. That's good.
Yeah.
So
So
I'm
now
just
we
going to
can
do
just
36.
Pythagorean theorem it.
Right, because it isn't a special triangle. And C squared is
Okay, that's 7225,
7225.
and the square root of that, drum roll, 85.
85. And so the answer's D.
Yeah.
So how many of you followed that, sort of? How many should I go over it again, Gabby?
That'd be like a real hard one.
You're just gonna have a great life. You sort of see it?
Even if you look at it later, it'll probably come to you. It's just multi-step.
Yeah, I just took the whole volume of I just had to get the slant height is just gonna be this right triangle in here. So first I had to get the radius was 77,
Then the height.
then the height was 36, and then I just worked it out. Okay, we're just going to do a couple more. We won't do the last page because we're running out of time here. So I'm going to go to 1066, number 15, see what's awaiting us there. Okay, a square A has side lengths. So let's try square B, and we're trying to get square A. It's 166 times the side length of square B. So the area of square A is K times the area of square B. 166 times. So let's call square B 2 times 2 is 4. I'm just picking numbers here. So 2 times,
I don't even, why don't we just pick one? One by one by, what's the area of square with a 1 by 1 by 1? It's going to be 1. It's going to
oh,
be even easier.
okay, we'll do it his way.
Let's make it real easy.
1 by 1 by 1.
Well, yeah, and then we'll have a 166 by 166 squared. We just have to see how bigger is A than whatever.
So 166 times 166 is 27556,
Right, which is the answer.
which is our answer. So that one wasn't too bad, was it? You girls having fun yet? Okay, and just one more. uh 1077, number 10. And we did one like this with surface area. 1077, number 10. Okay. A cube has a volume of 474. And this is higher difficulty at the end, sort of.
552.
552, thank you.
Mhm.
So that we know that's the area of the cube,
And that's the volume of the
or
cube.
the volume, sorry. And we want to get the surface area.
Oh yeah, we want to get a side first, probably.
So we have to get the side. So you put the cube root, or you could just put this to the 1/3 power, which I sometimes do. And each side of the square is
78.
78. And so to get the surface area, we did one like this.
It's
Six
sides, right?
6s squared. So that'll be 6 times 78 times 78, which comes out to number crunching. We did one with more reasonable numbers. So is that good for everybody? Yay. Okay, let's take a break to win.
Well, right, yeah, take a break. Break till 7:30.
Okay. That gives them, okay.
You know, I think yeah, 7:30 sounds good because that'll leave me some time.
Okay. We'll see you in 10 minutes or 11 minutes.
All right, it's 7:30, so we should be back. So let me know if you're back. Oh, Julie's back. Hey, we're gonna do information and ideas. Sailor's back. I'll bring up the packet while you guys find your copy. Okay, here we go. Here's the packet. So it's just reading comprehension today. Gabby's back. We're just doing this packet. All right. So we're going to look at central idea and details questions. We'll look at command of evidence questions, informational graphics, and inferences. And this is 26% of the English. This is a big chunk of the test, actually. It's really just reading comprehension. Okay, so there are main idea questions. We'll start out with that because it's a very common question type. So they'll give you a paragraph of text, they'll give you a passage, and then they'll ask this question: which choice best states the main idea of the text? And we just have to keep in mind one thing: main idea. It's hard to write on this tablet. Yikes! Versus detail. So details are factually true and they are contained within the passage, which is why you could be tempted to pick a detail. But when we're looking for the big picture, we're looking for like the why of the passage. Why does it exist? Why was this even written? What are we trying to learn? What is, like in broad strokes, what is this mainly about? So often they'll pick out some little minutia, they'll pick out little details from the passage, and those will be answer choices. And because they're factually true and they were contained within the passage, it can be a little tricky. So we'll try this one together before we do some other ones. But I'm going to read the passage. We just have to separate main idea versus detail among the answer choices. So here's the passage. You guys can hear me okay? Okay, good. In the 1800s, before the Industrial Revolution, 90% of the world's population lived on farms. Today, the number is closer to 1%. Increased mechanization in farming partially led to this change, as fewer were needed to cultivate the land with nascent automation of tilling, planting, and harvesting. Primarily, however, it was the newly developed factory and urban centers for the production of textiles that drew many away from the traditional vocation of farming. Automated looms in factories now produce the vast majority of fabric that had once been hand woven. The earliest of these textile factories began in England, but soon spread to the US. By the time of the American Civil War, there were over 1,200 cotton factories and 1,500 woolen factories in the US. Okay, so that's the passage, and now we're looking for the main idea of the text. I'm just going to read a few answer choices. A says mechanized farming methods vastly improved the efficiency of agriculture in the 19th century, leading to a reduced farming workforce. So, could that be the main idea of the passage, or is that a detail? It's a detail, and we can tell that it's a detail because where's the textile industry? Where's the whole second half of this paragraph? You see how that's just a detail from the beginning of the passage? We have to encompass the entirety of the passage. We want the main idea, we want everything. So that's too much of a detail. What about C? The textile industry soon dominated Europe and the US as automated looms produced the vast majority of fabric that had once been hand woven. So that too is a detail because where's the farming? Where is mechanization in farming? We don't have anything, right? So we can't claim that that is the main idea of the entire paragraph of the entire passage because we don't have any mechanized farming methods, anything like that. Even answer choice D is a detail. It's factually true. It's right from the passage, but again, no mechanization in farming. It can't encompass the entirety of the whole passage. But what about B? Could this be the idea why we're reading this? One of the most profound effects of the Industrial Revolution was the mass movement away from a farming focus and rural setting to a manufacturing interest in urban setting. So now we have the farming, the change in farming, and we also have the the additional factories, the textile industry. All right, so that was just a general idea of differentiating between main idea and detail. The only tricky thing about it is that details are true. So you just have to, just separate what is the big picture, what am I, really trying to learn versus, a smaller portion of the passage. But they can also ask you questions about details. They could test your understanding of details. They're not saying that details aren't important or anything. You'll just get a different type of question where instead of asking about what is the main idea, they'll ask about a detail. They'll say, and I always like to read these prompts first, even before I read the passage, so that way I sort of know what I'm looking for. It says, what does the text most strongly suggest about tool use with regard to Homo habilis? Okay, so I'm going to read the passage, and then we just have to come up with something uh, that makes sense. I'm going to read the passage. It sounds like a science passage. Homo habilis had a larger brain case than the older hominid Paranthropus robustus, and its corresponding greater intelligence may have allowed it to make the jump to solving problems using tools. Unlike Paranthropus robustus, which had a large cranial ridge to support the muscles needed to crunch through tough food, as well as massive teeth and jaws, the features of Homo habilis were relatively delicate. It is thought that the use of stone tools to process food allowed Homo habilis to rely less on its teeth and gradually lose these robust features. This transition continued all the way to the anatomically modern human, Homo sapiens. So, what does the text most strongly suggest about tool use with regard to Homo habilis? I'm going to go through some answer choices. A says, if Homo habilis would have had a smaller brain case, then modern humans may not have existed in their current form. So watch out for hypothetical answers on the SAT. If it sounds incredibly hypothetical, like we couldn't possibly know the answer, it's just wrong. We'll see some more examples right from the blue book, I hope tonight. But if it sounds incredibly hypothetical, it is incorrect. It is the wrong answer choice. Um, could we even know what would have happened had Homo habilis had a smaller brain case? Do you see how hypothetical this is? But more importantly, the passage just never makes this claim. The passage never mentions anything about what would have happened had Homo habilis had a smaller brain case. But just look out for really hypothetical things. I hope we run into this again, but they love to do this. They love to pick really hypothetical answers. It just they'll have you pondering, while like the clock is ticking. What would have happened, all right, what about C? Paranthropus robustus shared many traits in common with Homo habilis. So is that the point of the passage? Are we trying to show how similar Homo habilis is to Paranthropus robustus? No, they're very different. So Paranthropus robustus has the robust features. It has the large cranial ridge to support the muscles, as well as the massive teeth and jaws it would need to eat food without tools. The features of Homo habilis, on the other hand, are relatively delicate. So Homo habilis lacks these robust features, and can't rely on them. So the point of the passage isn't their similarities. The point is their differences. Really, they're very different, it seems. D says many types of hominid have developed tool use. Does the passage ever make that claim? No. That's probably a true statement, though. I've heard that chimps use tools. They're hominids. So I don't know, but don't bring anything into the passage that isn't here. The passage never makes this claim. It just does not say anything about this. But we could go with B. This does make logical sense. Tool use played a key role in the transition from mankind's ancestors to modern humans. Even if we read the last, Even if we read the last sentence of this passage, I think this gives us answer choice B. This transition continued all the way to the anatomically modern human Homo sapiens. So the less robust features, the more delicate features, and accompanied with tool use. Okay. So that one was B. They might ask you about a detail. Watch out for things that are incredibly hypothetical. All right. Next. are command of evidence questions. Okay, so it's just more reading comprehension. So there are text-based evidence questions like this. Here we have a novel by Dickens, and they're going to give us four quotations from the novel. They don't expect us to have read David Copperfield. I bet this book is 400 plus pages long. Victorian novels tended to be pretty long. All we need is this. This is all we need of this monster of a book. We need four quotations. So let's see what we're trying to prove or support, or what yeah, this is, and you might want to underline this prompt when you're taking a test in Blue Book. The software permits you to underline portions of the question, and I might do this. I might say in the novel, Dickens describes this character, James Steerforth's propensity to condescend in his behavior towards others, as evident in this interaction at the boarding school. So we're just going to read the quotes and see. I'm looking for condescending behavior uh, by Steerforth. I'm going to try A. A says, but the greatest wonder that I heard of Mr. Creakle was there being one boy in the school on whom he never ventured to lay a hand, and that boy being J. Steerforth. So I don't see any condescending behavior by Steerforth in that one. I'm just going to keep going. I heard that Miss Creakle was regarded by the school in general as being in love with Steerforth, and I am sure, as I sat in the dark thinking of his nice voice and his fine face, and his easy manner and his curling hair, I thought it very likely. So I don't see any condescending behavior here by Steerforth, any patronizing behavior. I'm going to keep going. What about D? Steerforth continued his protection of me and proved a very useful friend, since nobody dared to annoy one whom he honored with his countenance. I don't see any condescending behavior by Steerforth. That's the only thing we're looking for. So it had better be in C. In this, I was much assisted by Mr. Mell, who had a liking for me that I am grateful to remember. It always gave me pain to observe that Steerforth treated him with systematic disparagement, and seldom lost an occasion of wounding his feelings or inducing others to do so. So there's the condescension. That's what we were looking for. He was condescending toward Mr. Mell, apparently. Great. So we got the right answer, and that's all we need of David Copperfield. I kind of like that. These excerpts are actually pretty short. That didn't take me very long to read four quotations and pick one. Okay, so moving along. Okay, what about quantitative evidence? So they might give you a question about quantitative evidence. So you're trucking along in the English section, and suddenly you see a graph. Yes, they're on the test. They're on the English. You may ask yourself, is this a math question? What's going on here? I thought I was doing English. It's just reading comprehension. They just want to know, can you read a graph? So that's all we have to do. There are three types of infographic on the SAT. There are line graphs like this. There are bar graphs, kind of look like this. And then the third kind are tables. So they might just give you numbers, data. So those are the three types of infographic on the test. And we have a line graph here. So I like to always read the title of the graph. I always like to read the X and Y axes, I guess. And if they give you a key, I like to read that too. I'd like to just get a general idea of what's going on when I do one of these. So the title says percent errors made for line length comparison for 1 to 15 Confederates. Our x-axis are number of Confederates, and then y-axis would be percent errors. Okay, great. So I'm going to read the experiment, and then we just have to answer the prompt. I like to read the prompt first. This is the prompt. Which conclusion can be drawn from the graph? So we are going to have to use the data, basically. So I'm going to read the experiment, and then we'll figure out what we can say about the data. Here is the experiment. I'm just going to read this. An experiment was performed in which one participant was the actual subject of the experiment. The subject was placed within a group of one or more other participants who were Confederates. They were in league with the experimenter, and their answers were carefully scripted. The true subject was unaware of this fact. The participants were shown one vertical line on a card, followed by another card with three lines labeled A, B, and C. One of these lines was equal in length to that of the first card, and the other two lines were obviously longer or shorter. Each participant was asked to state the letter name of the line that matched the first line in length. The participants were seated so that the real subject always responded last. On the first two trials, the Confederates unanimously chose the correct lines, but in all subsequent trials, they would unanimously select the same incorrect line. There were 15 trials in total. The experiment is repeated with different subjects and incrementally larger numbers of Confederates, from 1 to 15 total. The graph above displays the percentage of errors the subjects made with the corresponding number of Confederates present. Okay, so now that I've read the experiment, I guess it makes a little more sense to me. We're adding Confederates, and then it looks like errors are going up with additional Confederates. Although the data is kind of interesting in that it seems to plateau at around 35%. All right, so I'm going to go through some answer choices. What about A? Subjects erred less when presented with a greater number of Confederates. No, I know it's going up. I know that the more Confederates that we add up to a certain point, the more that are made. So it can't be A. B, the number of Confederates had no effect on the percentage of errors the subjects made. I think that this is definitely having an effect, right? Okay, it's changing the data. What about C? The percentage of errors the subject made increased with each additional Confederate. Well, if that were true, our data would look like this. It could be linear increasing. Oh, you know what? It could even be exponential increasing. That would still be increasing with each additional Confederate, but that's not what's happening. We don't have anything like that. It looks like we're adding some Confederates and it's going up. The number of errors are going up, and then they're around 35% for a while. It's trending upwards. Okay, so C is out. What about D? Subjects erred when presented with a group of four Confederates as readily as they did to a larger group. Let's find four Confederates. All right, I'm just going to go up. All right, so if we have four people yelling out the wrong answer, is that about the same as nine people yelling out the wrong answer? Sure. Or 12 or 14. So it doesn't seem after a certain point. I mean, it definitely affects us early on. But once we have enough people yelling the wrong answer at us or responding incorrectly and we answer last if we're the true subject, it seems like it affects us about 35%, all these extra Confederates. All right, so that one was D. Can you read a basic little line graph? You're never gonna have to do any actual math. They're never gonna ask you to find the slope of a line or something. It's always gonna be something like this. Can you just compare it to an experiment, answer a simple question about I mean, they can make them tricky. Don't get me wrong. Hopefully we're gonna see a tricky one in a little bit, but that one wasn't too bad. All right, here they can ask us to draw inferences. All right, so here's an inference question. So which choice most logically completes the text? So one of these answer choices is just going to go right in this blank. And we're drawing an inference here because it's just going to be the one that seems most appropriate based on the scenario. So it says in 1895, German physicist Wilhelm Röntgen discovered and named the X-ray. He was experimenting with various vacuum tubes by passing electrical charges through them. Even though the vacuum tube he was using was shielded by cardboard, a screen 9 feet away suddenly changed another color. He hypothesized correctly that this occurrence must have been caused by an unknown ray, not knowing what, and then we have a blank. So I'm going to go through the answers, or I'm just going to read them, and then we can decide what logically makes the most sense. Not knowing what type of ray it was, Röntgen called it X to designate it as an unknown type of radiation. B says what not knowing what to call it. Many of his colleagues suggested calling them Röntgen rays. C says not knowing what could have caused this phenomenon, more study would be necessary. D, not knowing what had happened, Röntgen would later use it to reveal the bone structure of his wife's hand. So answer choices C and D imply that Röntgen didn't know what was happening, but the passage shows us that he knew what was going on. The passage says he hypothesized correctly that this occurrence must have been caused by an unknown ray. So C and D are out because they imply he doesn't know what is happening, but the passage tells us what is happening. So we already have it down to A or B. It's a coin toss if we randomly guess at this point. But the first sentence, I think, is critical here. If you're reading too quickly, maybe you weren't paying attention. But the first sentence says Röntgen discovered and named the X ray. So we know it's an X-ray, and we know that he named it, not his colleagues. That's why it's A. But if you're reading too quickly, you may have missed that entirely. Um, yeah, so that's an inference one. We had to draw a little bit of an inference, but it really wasn't even that much because we know they're X-rays. We even know that he named it, so it kind of has to be A. But though they can make them a little harder. That was like an easy one, maybe. We start with the easy ones. Okay, so now we have our actual SAT questions. We have, let me see how many we have. All right, we have an informational graphic question. We have five total here. So I'm going to give you guys some time to do all five of these. Probably a little bit more than 5 minutes just because of this table. This one might take a little longer to read. But we're going to take a few minutes, maybe like 7 or 8 minutes. Just try these five. We'll go over all five, uh, but just try all the way up to here. And we're going to keep track of how many we get right. So try five of these and give you guys some time to do them. And we'll go over these at about 8 o'clock. All right, it's 8 o'clock, and I can tell. I can just see everyone's finished. So we're gonna go over these ones. Let's start with the table. All right, so we have a table. I like to read the prompt. I think you should always read the prompt first, just so you know what you're looking for when you go back and read the experiment. It says which choice uses data from the table to most effectively support the researcher's conclusion. So I will be looking for their conclusion as I read the passage. And I always like to read the title of the table. I like to get a general idea of what the data is, even before I read the passage. So it says relative duration of gaze of infants at six stimulus objects. We have face, bullseye, news, white, yellow, red. So those must be the objects. That's mean percentage fixation time. That's what all the data is. And then we have age groups. We have under 48 hours old, we have 2 to 5 days old, and 2 to 6 months old. So those are the infants in different categories. So now I'm going to read the experiment. It says psychologist Robert L. Fonts and colleagues conducted an experiment in which 18 infants from 10 hours to 6 months old were placed in a crib on their backs to view a series of 6 images in random order from 1 foot away. The 6 images were all circular in shape, 6 inches in diameter, and non-glossy. 3 images contained black and white patterns, an illustrated face, a bullseye, and newsprint. 3 images contained plain colors, white, yellow, and red. The researchers recorded the duration of each infant's gaze on the images by monitoring the reflection of the target image in the infant's eyes. Based on analysis of the relative duration of fixation time of the infants, the researchers concluded that infants across all age groups showed significantly greater visual attention to patterned surfaces in comparison to plainly colored surfaces. So if I were taking a test on Blue Book, I can underline things. I'm going to underline things right now. I wanted the researcher's conclusion, so I'm going to underline it. Here it is. We're looking to prove this with numbers. Can we do it? Okay, so we have two different types of image. We have patterned images and we have plain images. So the patterned images are face, bullseye, and news. Those are patterned. The plain images, I'm gonna change colors here. These are plain colors, white, yellow, and red. So those are the plain images. Okay, and just noticing is there any difference in data? What's going on with this? Might be helpful to realize. So they say that the infants across all age groups showed greater visual attention to patterned surfaces in comparison to plain colored surfaces. So here's answer choice A. Infants from 2 to 6 months old had a mean percentage fixation time of 8.2 on a plainly colored surface. Do we want to compare that to 10.1 on another plainly colored surface? We're comparing the duration of fixation time plane to plane. So we're not comparing pattern to plane. What about B? Infants from 2 to 5 days old had a mean percentage fixation time of 9.9 on a plainly colored white surface in comparison to 6.7 on the plainly colored red surface. Again, I'm comparing a plain colored surface to a plain colored surface, and even the numbers are very similar. Um, Okay, C. Infants under 48 hours had a mean percentage fixation time of 12.3 on a plain white colored surface in comparison to 11.5 on the plainly yellow colored surface. So I'm comparing plane to plane. What about D? Infants from 2 to 5 days old had a mean percentage time of 29.5. That's significant. On the face, on a patterned surface in comparison to 9.9 on the white colored surface, the plain surface. So they're spending the infants from 2 to 5 days old on average 3 times as long looking at a patterned face image compared to a plain color. So that supports the researchers' conclusion that they spend greater visual attention on pattern, or they give greater visual attention to patterned surfaces compared to plainly colored surfaces. So that one wasn't too bad. And really, these numbers should have kind of jumped out at you as being much higher than these numbers, I would hope. Okay, moving along. It's a main idea question. These are all over the test. If you look at the prompt, you can tell it's a main idea question. So watch out for details. We want the main idea versus detail. So the tricky thing is details are true. There will be true statements from this passage as answer choices. We just have to look for the big picture. All right, here we go. Since 1995, physicists have been able to cool atoms down to billionths of a degree above absolute zero to create a single quantum state known as a Bose-Einstein condensate. Since then, physicists have desired to create Bose-Einstein condensates out of molecules, and recently they have succeeded. Molecules are more intricate than atoms and interact with one another in different ways. This new development could lead to a revolution in quantum computing. Okay, so I'm looking for the main idea. Here's answer choice A. Molecules are more complex than atoms and interact differently than atoms. That's a true statement. It's a fact right from my passage. It is a detail. We should notice when we hit the main idea. C, creating Bose-Einstein condensates requires cooling substances to near absolute zero. That's true. That's right from the passage. It's the first sentence. That is a detail. It's not mainly why we are reading this passage. It's just a detail. D, scientists have created Bose-Einstein condensates out of atoms since 1995. That's a true statement. It is, of course, a detail. Why are we even reading this passage? Well, now scientists have been able to create Bose-Einstein condensates out of molecules rather than just atoms. That's why we're interested. That's why we care. That was the main idea, not just a detail. That's the important thing. So we know they've been making them out of atoms for a long time. Since I'm just going to read right from the passage. Physicists have desired to create Bose-Einstein condensates out of molecules, and recently they have succeeded. So that was the main idea of the passage. On to number 3. Here is an excerpt from a novel. This is The Age of Innocence by Edith Wharton. And this is another long book. She wrote long books. She wrote House of Mirth. She wrote some this book's probably 400 or 500 pages long. But we just need a paragraph. All we need is this much of it. They don't expect you to have ever read this book. All we need is right here. Always read the prompt first. It's going to save you time. Based on the text, how do members of New York society most likely regard Mr. Sillerton Jackson? So that's what I'm looking for. So now I'm going to read the passage and let's see if we can come up what they would say about him. In addition to in addition to this forest of family trees, Mr. Sillerton Jackson carried between his narrow hollow temples and under his soft thatch of silver hair a register of most of the scandals and mysteries that had smoldered under the unruffled surface of New York society within the last 50 years. So far indeed did this information extend, and so acutely retentive was his memory, that he was supposed to be the only man who could have told you who Julius Beaufort the banker really was. And what had become of handsome Bob Spicer, old Mrs. Manson Mingott's father, who had disappeared so mysteriously, with a large sum of trust money, less than a year after his marriage, on the very day that a beautiful Spanish dancer who had been delighting thronged audiences in the old opera house on the Battery, had taken ship for Cuba. But these mysteries, and many others, were closely locked in Mr. Jackson's breast, for not only did his keen sense of honor forbid his repeating anything privately imparted, but he was fully aware that his reputation for discretion increased his opportunities of finding out what he wanted to know. Okay, so What would members of New York society most likely think about Mr. Sillerton Jackson? A. Most dislike him for his propensity to gossip. I don't think we have anything in the passage to indicate that most would dislike him for his propensity to gossip. I think we would be bringing something into the situation if we were to pick A that isn't there, I mean to say. B says, some view his tales to be greatly exaggerated. Is there anything in the passage that indicates he is exaggerating or lying or just increasing the extent of things? I don't think so. Nothing in there shows me that he's exaggerating. Many believe he is lacking in moral character. Is there anything in the passage to indicate that he is unethical or lacking in moral character? I don't think so. What about D? Few would fear that he would divulge their secrets. Can I find some evidence that would support D? Sure. He has a keen sense of honor that forbid his repeating anything. He has a reputation for discretion. So there you go. We could safely pick D. I found two pieces of evidence. There might even be more in there, but we yeah, they're closely locked. These secrets are closely locked in his breast. I found three examples of evidence. All right, we're gonna keep going. A lot of evidence supports D. On to number four. Okay. William Henry Johnson was a prolific African American painter who produced works in the US and in Europe. In an essay about Johnson's work, a student claims that later in his career, Johnson developed a simplistic style influenced by folk art. I may want to underline the claim because I am looking for evidence of this claim. And if I underline it right in Blue Book, they let you, maybe it'll be easier for me to find evidence for this. All right, let's see which quote from an art critic best supports the student's claim. That is the prompt. I know I said I'd read the prompts first. I really should. Anyway, many African Americans who traveled to Europe returned with new perspectives. Johnson, who had two long episodes abroad, was no different. So I don't see a simplistic style. I don't see any mention of folk art. I'm going to keep going. European influences on Johnson's early work were many. He was clearly influenced by post-impressionists, including Van Gogh. Okay, post-impressionism, Van Gogh. I'm not seeing folk art or a simplistic style. I'm going to keep going. What about D? Following the death of his wife, Johnson's physical and mental health deteriorated and he was institutionalized. He ceased to paint after 1955. So I don't see any folk art or a simplistic style in D. What about C? This period saw a marked change from his earlier modernist and expressionist influences. He drew on his rural southern upbringing and naive figures of African American traditionalism would dominate his canvases. So there's the folk art, and there's the simplicity we were looking for. All right, that one wasn't too bad. Last one. This is an excerpt from a short story, Bartleby. Let's read the prompt first. Let's do what I suggested. I know it's hard to remember sometimes. Based on the text, what is true about the narrator? The narrator is always the teller of the story. In this case, it's this singular pronoun I. That this guy is our narrator. All right, I'm going to read the passage. I am a man who, from his youth upwards, has been filled with a profound conviction that the easiest way of life is the best. Hence, though I belong to a profession proverbially energetic and nervous, even to turbulence at times, yet nothing of that sort have I ever suffered to invade my peace. I'm one of those unambitious lawyers who never addresses a jury, or in any way draws down public applause, but in the cool tranquillity of a snug retreat do a snug business among rich men's bonds and mortgages and title deeds. All who know me consider me an eminently safe man. Okay, what is true about the narrator based on that? He wishes he could attain public prestige by presenting more important cases before a jury. I don't think the passage ever makes that claim. He's not that kind of lawyer. He suffers from not being well compensated for his services. I don't think that's true. He does a snug business among rich men's bonds and mortgages. So that one's out. D, he, like most lawyers, inhabits a career that is fast-pacing and anxiety-inducing. Well, we know from the passage that he never lets that invade his peace. We could go with C, he is content with the ease and efficiency of his chosen path. The easiest way of life is the best. So that's what our narrator does. So our narrator is more like C. Add up how many you got right out of five. Maybe I just missed one. 4 out of 5 would still be pretty good. We're going to do some book ones with our remaining time. I'm just going to give you a page number. Do some book ones. I might even just trim this down a little bit. I'll give you the page number first. Page 119. So find your blue book. And I think I'm just going to pick a few of these. I think we have 12 here, but I don't want to do that many. I'm just going to pick some. Let's do one. Let's do three. Let's do five. Yeah, let's do five. Let's do six. That's a hard one. Let's skip six. Let's do five, seven, eight. Some of these are easy. Some of them are hard, though. Just like the real test. Let's do eight. Let's do nine and 12. Yeah, so we'll just do seven. So just try these seven, and I'll give you guys some time to try them, and then we will go over them. We don't have a ton of time. Let's take off eight and nine. Let's just do five. Okay, I'll let you guys work. All right, we're running out of time. Did anyone finish all five? Did anyone try all five? Oh, everybody. Okay, then we'll just quickly grade them, and we'll be done on time, I promise. So I'm not gonna spend too much time on this. I'm glad you guys tried a few, and you may want to try the rest of these later. You can always see the kind of questions that you're missing when you take a test. Oh, I missed some information and ideas questions. I need to work on that, or standard English conventions or whatever. So we have the ice melting here, right in our passage. Ice melted, so that indicates high temperature. All right, but the sandal was well preserved for centuries by the ice, so that's low temperature. Okay. Can we trust any incredibly hypothetical answer choices like B? Can we wouldn't know that. Or D is even more hypothetical. They would have found it eventually? We can't possibly know that. Was it a Roman sandal? They're trying to trick you. It's like those worn by Romans, but it's not a Roman sandal even. It's C. Temps contributed both to the protecting and revealing of the sandal. All right, number two. Okay. So based on the story, what how do people in this capital of Mexico most likely regard Dr. Mao Sufrito? So if you picked A, you got this one right. There's some evidence. There's some evidence. Okay, I'm gonna keep going just because we don't have a lot of time. All right, number three. All right, so which choice expresses the main idea of this passage about Mimas? All right, so we have a wobble in Mimas. All right, A. Rodin and colleagues were the first to confirm that several of Saturn's moons contain hidden oceans. That's not in the passage. What about B? Research has failed to identify signs that there is an ocean. I think they have identified it. C says Rodin and colleagues created a new computer model that identifies moons with hidden oceans. Is that what their model does? I don't think so. We can go with D. Research has revealed that an oddity in the rotation of Mimas could be explained by an ocean hidden beneath its surface. All right, on to number five. Okay, so five says Pulitzer Prize winning writer Hector Tobar has built a multifaceted career as both a journalist and an author of short stories and novels. In an essay about Tobar's work, a student claims that Tobar blends his areas of expertise by applying journalism techniques to fiction, which, quote, supports the student's claim. For one novel, an imagined account of a real person's global travels, Tobar approached his subject like a reporter, interviewing people the man had met along the way and researching the man's own writings. So that one was A. All right, we're skipping that one. All right, the toad one. The toad one is pretty tricky. And I don't have a ton of time to explain this, but I'm going to do my best to quickly explain this toad situation. So we have tadpole body mass and toxin production after 3 weeks in ponds. The important columns to answer this question are this column. This is the toxin concentration. We're going to need that. We're going to need the body mass concentration, or sorry, average body mass of the tadpoles. So what you hopefully noticed, which choice uses data from the table to most effectively support the researcher's conclusion? What was the researcher's conclusion? It's this: increased competition drove bufadenolide production, that's the toxin, at the expense of growth. So hopefully you noticed when the population density of the toads is high, there is a higher concentration of the toxin and a lower body mass. And when the population density of the toads is low, they weigh more, body mass is higher, and the toxin is lower. And if you correctly identified that's the important part of this passage, you should have picked answer choice B. All right, I'm out of time, but I'm just going to give you that last answer. So we were going to do 12 as well. It's about crabs. All right. Yeah, it's this last one. I'm just going to give you the answer. So check your work. You should have got B for number 12. All right. So you can add up how many you got right out of five if you want. Hopefully it's pretty good. And any questions? Are you guys good? And we'll just see you guys next time if you guys are great. Uh, Everyone seems to be going up with the practice test, so we're really happy with that. So we're just gonna, I think everything's good if you guys are good. Everyone happy? Okay. All right. Well, have a great night and have